An industry refers to an economic activity that is concerned with the production of goods from raw materials, extraction of minerals, or the provision of services useful to man. Thus, we have iron and steel industry, which is mainly concerned with the production of goods, coal mining industry for extraction of coal, and tourism industry, which is a service provider. The history of steel making in India can be traced back to 400 BC, when the Greek emperors used to recruit Indian archers for their army who used arrows tipped with steel. Many more evidences are there of Indians' perfect knowledge of steel making long before the advent of Christ. Archaeological finds in Mesopotamia and Egypt testify to the fact that use of iron and steel was known to mankind for more than 6,000 years, and that some of the best products were made in India. Among the widely known relics is the iron pillar near Qutub Minar in Delhi. The pillar, built between 350 and 380 AD, did not rust so far, an engineering marvel that baffles the scientist even today. Yet another engineering feat is the famous Sun Temple at Konark in Orissa, built around 1200 AD, where steel structurals were used for the first time in the world. These were the halcyon days when India flourished in all directions and when its prosperity was a matter of envy for the foreigners. But as ill luck would have it, India's prosperity gave way to poverty after the advent of the foreign rule. India's indigenous industry languished because of a deliberate policy of the colonial rulers to make the country only a supplier of raw materials. Steel role plays a vital role in the development of any modern economy. The per capita consumption of steel is generally accepted as a yardstick to measure the level of socio-economic development and living standards of the people. As such, no developing country can afford to ignore the steel industry. Industries can be classified on the basis of raw materials, size, and ownership. Firstly, coming to raw materials. Industries may be agro-based, mineral-based, marine-based, and forest-based depending on the type of raw materials that they use. Now, let us have a look into the agro-based industries. Agro-based industries are those industries which use plant and animal-based products mainly procured from agriculture as their raw materials. Food processing, vegetable oil, cotton textile, dairy products and leather industries are examples of agro-based industries. Next comes the mineral-based industries. Mineral-based industries are classified as primary industries that use mineral ores as their raw materials. The products of these industries feed other industries and act as raw material for other industries. Iron made from iron ore is the product of mineral-based industry. This is used as a raw material for the manufacture of a number of other products such as heavy machinery, building materials and railway coaches. Now, next comes the marine-based industries. Marine-based industries use products from the sea and oceans as raw materials. Industries processing seafood or manufacturing fish oil, algal products, single-cell proteins are some of the examples. Now, the next type is the forest-based industries. Forest-based industries utilize forest produce as raw materials. The industries associated with forests are pulp and paper, pharmaceuticals, furniture and buildings. Next comes based on ownership. Industries can be classified into private sector, state-owned or public sector, joint sector and cooperative sector. First comes private sector. Private sector industries are owned and operated by individuals or a group of individuals. The public sector industries are owned and operated by the government, such as Hindustan Aeronautics Limited and Steel Authority of India Limited. Second is the joint sector. Joint sector industries are owned and operated by the state and individuals or a group of individuals. Example, Maruti Udyog Limited. Next comes cooperative. Cooperative sector industries are owned and operated by the producers or suppliers of raw materials, or workers, or both. Anand Milk Union Limited and Sudha Dairy are success stories of a cooperative venture. The iron and steel industry is the basic industry, since all the other industries such as heavy, medium and light depend on it for their machineries. Steel is needed to manufacture a variety of engineering goods, construction materials, in defense equipments, medical such as in case of surgical steel, telephonic, scientific equipment and a variety of consumer goods. Production and consumption of steel is often regarded as the index of a country's development. Iron and steel is a heavy industry because all the raw materials as well as finished goods are heavy and bulky, entailing heavy transportation cost. Today, with 32.8 million tons of steel production, India ranks 9th among the world crude steel producers. It is the largest producer of sponge iron. In spite of large quantity of production of steel, the per capita consumption per annum is only 32 kg. In the 1950s, China and India produced almost the same quantity of steel. Today, China is the largest producer. China is also the world's largest consumer of steel. In 2004, India was the largest exporter of steel, which accounted for 2.25% of the global steel trade. Chota Nagpur Plateau region has the maximum concentration of iron and steel industries. It is largely because of the relative advantages this region has for the development of this particular industry. These include low cost of iron ore, high grade raw materials in nearby proximity, cheap labor and vast growth potential in the home market. Though India is an important iron and steel producing country in the world, yet we are not able to perform all our fulfill potential, largely due to, firstly, the high cost and limited availability of cooking coal, secondly, lower productivity of labor, third, irregular supply of energy, and finally, because of poor infrastructure. The world's major industries are the iron and steel industry, the textile industry and the information technology industry. The iron and steel and textile industry are the older industries compared to the other emerging industrial sectors. The countries in which iron and steel industry is located are Germany, USA, China, Japan and Russia. Textile industry is concentrated in India, Hong Kong, South Korea, Japan and Taiwan. Like other industries, iron and steel industry too comprises various inputs, processes and outputs. This is a feeder industry whose products are used as raw material for other industries. The inputs for the industry include raw materials such as iron ore, coal and limestone, along with huge labor, capital investments, site and other infrastructure. The process of converting iron ore into steel involves many stages. The raw material is put in the blast furnace where it undergoes smelting. It is then refined. The output obtained is steel, which may be used by other industries as a raw material. Iron is a chemical element with the symbol Fe and atomic number 26. In terms of mass, it is the most common element on Earth, forming much of Earth's outer and inner core. It is the fourth most common element in the Earth's crust. Iron metal has been used since ancient times through copper alloys, which have lower melting temperatures, were used first in history. Pure iron is soft, sometimes softer than aluminium, but is unobtainable by smelting. The material is significantly hardened and strengthened by impurities such as carbon from the smelting process. A certain proportion of carbon between 0.002% and 2.1% produces steel, which may be up to 1000 times harder than pure iron. Crude iron metal is produced in blast furnaces where ore is reduced by coke to pig iron, which has a high carbon content. Further refinement with oxygen reduces the carbon content to the correct proportion to make steel. Next, coming to the industrial production of iron. The production of iron or steel is a process containing two main stages unless the desired product is cast iron. The first stage is to produce pig iron in a blast furnace. Alternatively, it may be directly reduced. The second is to make wrought iron or steel from pig iron by a further process. Now, let us understand about the blast furnace. 90% of all mining of metallic ores is for the extraction of iron. Industrially, iron production involves iron ores, principally hematite called Fe2O3 and magnetite, which is Fe3O4, in a carbothermic reaction. Carbothermic reaction is a reaction which happens with the reduction of carbon in a blast furnace at temperatures of about 2000 degrees centigrade. In a blast furnace, iron ore, carbon in the form of coke and the flux such as limestone are fed into the top of the furnace, while a massive blast of heated air is forced into the furnace from the bottom. In the furnace, the coke reacts with oxygen in the air blast to produce carbon monoxide. The equation is 2C plus O2 giving 2CO, which is carbon monoxide. The carbon monoxide reduces the iron ore in the chemical equation below, that is hematite, to molten iron, becoming carbon dioxide in the process. The equation is Fe2O3 plus 3CO giving 2Fe plus 3CO2. Some iron in the high temperature lower region of the furnace reacts directly with the coke. The equation is 2Fe2O3 plus 3C giving 4Fe plus 3CO2. The flux is present to melt the impurities in the ore, principally silicon dioxide, sand and other silicates. Common fluxes which are used include limestone, which is principally nothing but calcium carbonate, and dolomite, which is calcium magnesium carbonate. Other fluxes may be used depending on the impurities that need to be removed from the ore. In the heat of the furnace, the limestone flux decomposes to calcium oxide, also known as quicklime. The equation is CaCO3 giving CaO, that is calcium oxide, plus CO2, which is carbon dioxide. Then calcium oxide combines with silicon dioxide to form a liquid slag. The equation is CaO, which is calcium oxide, plus SiO2, which is silicon dioxide, giving CaSiO3, which is slag. This slag melts in the heat of the furnace. In the bottom of the furnace, the molten slag floats on top of the denser molten iron, and apertures in the side of the furnace are opened to run off the iron and the slag separately. The iron, once cooled, is called pig iron, while the slag can be used as a material in road construction or to improve mineral poor soils for agriculture. Now, the next method of manufacture is by the direct iron reduction. Since coke is becoming more stringently regulated due to environmental concerns, alternative methods of processing iron have been developed. Direct iron reduction reduces iron ore to a powder called sponge iron or direct iron that is suitable for steel making. There are two main reactions that go on in the direct reduction process. First is, natural gas is partially oxidized, that is with heat in the presence of a catalyst. The equation is 2CH4 plus oxygen, that is O2, giving 2CO plus 4H2. These gases are then treated with iron ore in a furnace producing solid sponge iron. The equation is Fe2O3 plus CO plus 2H2, giving rise to 2Fe plus CO2 plus 2H2O. Now, silica is removed by adding a limestone flux later on. Pig iron is not pure iron, but has 4 to 5% carbon dissolved in it, with small amounts of other impurities like sulfur, magnesium, phosphorus and manganese. As the carbon is the major impurity, the pig iron becomes brittle and hard. This form of iron, also known as cast iron, is used to cast articles in foundries such as stoves, pipes, radiators, lampposts and rails. Alternatively, pig iron may be made into steel or wrought iron. Various processes have been used for this, including finery forges, puddling furnaces, Bessemer converters, open hearth furnaces, basic oxygen furnaces and electric arc furnaces. In all the cases, the objective is to oxidize some or all of the carbon together with other impurities. On the other hand, other metals may be added to make alloy steels. The hardness of the steel depends upon its carbon content. The higher the percentage of carbon, the greater the hardness and the lesser the malleability. The properties of the steel can also be changed by several methods. Annealing involves the heating of a piece of steel to 700 to 800 degrees centigrade for several hours and then gradual cooling. It makes the steel softer and more workable. Steel may be hardened by cold working. The metal is bent or hammered into its final shape at a relatively cool temperature. Cold forging is the stamping of a piece of steel into shape by a heavy press. Wrenches are commonly made by cold forging. Cold rolling, which involves making a thinner but harder sheet, and cold drawing, which makes a thinner but stronger wire, are two other methods of cold working. To harden the steel, it is heated to red hot and then cooled by quenching it in water. It becomes harder and more brittle. If it is too hardened, it is then heated to a required temperature and allowed to cool. The steel thus formed is less brittle. Heat treatment is another way to harden steel. The steel is heated red hot and then cooled very quickly. The iron carbide molecules are decomposed by the heat but do not have time to reform. Since the free carbon atoms are stuck, it makes the steel much harder and stronger than before. Sometimes both toughness and hardness are desired. A process called case hardening may be used. Steel is heated to about 900 degrees centigrade and then plunged into oil or water. Carbon from the oil can diffuse into the steel, making the surface very hard. The surface cools quickly, but the inside cools slowly, making an extremely hard surface and a durable resistant inner layer. The iron and steel industry in India is one of the fastest growing sectors. The demand drives for the Indian iron and steel industry are increasing in the activities of automobile industry, real estate industry, transport industry, aircraft industry and shipbuilding industry, etc. India ranks 5th in the world in terms of production of steel. It is expected that India would become the second biggest producer of steel within the year 2016 and the production per year would be 137 million tons. Next, coming to the applications of iron and steel. The first application would be the low cost and high strength make iron and steel indispensable in engineering applications such as the construction of machinery and machine tools, automobiles, the hulls of large ships and structural components for buildings. Secondly, white cast irons contain carbon in the form of cementite or iron carbide. This hard brittle compound dominates the mechanical properties of white cast irons, rendering them hard but unresistant to shock. The broken surface of a white cast iron is full of fine facets of the broken iron carbide, a very pale silvery shiny material and hence the appellation. Third is, wrought iron is characterized by the presence of fine fibers of slag entrapped within the metal. Wrought iron is more corrosion resistant than steel. Coming to the fourth application, mild steel corrodes more readily than wrought iron but is cheaper and more widely available. Alloy sheets contain varying amounts of carbon as well as other metals such as chromium, vanadium, molybdenum, nickel, tungsten, etc. Their alloy content raises their cost and so they are usually only employed for specialist uses. The next application is that cast iron is an important form that is used in manufacturing pots, pans, skillets, ovens and trays. Cast iron has a heating element that is almost appropriate for cookware, cooking items and accessories. Stainless steel is used in kitchen cutlery, appliances and cookware. Iron, as we all know, is a lustrous silvery soft metal. Iron is the main component of steel and it is used in the production of alloys or solid solutions of various metals and non-metals, particularly carbon. Different types of steel are produced by adjusting the chemical composition and adapting any of the different stages of the making process.